Hello again, it's Cliff here from Down Under. I want to do a little video on Rapidturn work and tool offsets. I know this is a confusing subject for some of us, and when I first started getting into it I was confused about a couple of points. So I want to go over some of the concepts of work and tool offsets. And I think initially, if you're a bit confused about this subject too, make sure you've watched a couple of key videos. Mark have done some excellent videos on this subject. Mike Corliss has done a good video, and Daniel Rogi's done several videos. Specifically, I would say refer to Daniel Rogi's video, Cutting Your First Part on a Tormac Lathe. Now that's excellent because he goes into the concepts of work and tool offsets there. And this video is going to be based on those concepts, and I'm going to go into some of the grey areas perhaps a little bit more deeply, but if you haven't seen that video of Daniel Rogi's, I would start with that. Okay, so I'm going to assume that you've got a basic knowledge of work and tool offsets. You've seen the introductory beginners videos and you understand some of the basic concepts. You understand that the key position on the part is the center and the end of the part. So I'm going to use a pointed part to make that very apparent. The center line and the Z end. And you understand the key position on a tool is the cutting edge. I'm going to have a parting tool here and a conventional turning tool here. Alright, well the first thing I'm going to do is reference the machine. So we'll reference the Z, that's a longitudinal, we're going to rehome it. We'll reference the X, that's the diameter, rehome it. And we won't, okay, we'll do the Y as well. We'll reference the Y as well. Now if we go to the offsets page, you can see here I've started off with 0 on all the tool offsets and 0 on the DROs on the work offsets. So we are parked over the homing position on the X, Y and Z, and we have all zeros on the first 4 tools. Okay, there's a reason for doing that because I want to try and explain some of the concepts here. So we're parked over the reference or homing position, but we've zeroed our G54 out at that point. Now I'm going to bring the tool 1 tip down to the end of the work, and I'll just stop the video and do that now. So remember, the key position on the work is its end and its center, and there we have it set approximately on the end and the center, And if we were going to do gang tooling, which I suppose this video can include, we're set on the Y as well. So X, Y and Z is set on the tip. So you can see we've got the tool set there on X, Y and Z center of the part. Approximately. We're talking about concepts here. And you can see I've got the tool table up. And still everything is on 0. The first 4 tools I've got 0 values, and the work offset for G54 is currently set on 0. Just checking you can see that okay. But if you look down here on the DRO, you can see we've traversed to these positions. 507 on the X, that's a diameter value, and minus 183 on the Z. Now, what I'm going to set now is the first setting, which is the work offset. Not the tool offset, but the work offset. I've got tool number 1 loaded, and I'll go into that later, possibly, but just to be clear about it, I've got tool number 1 loaded, and I'm going to 0 it on the main DRO. 0, enter, and we could just push the button here on this one. And we'll do the Y as well. 0, enter. Okay, so there's 0. The tool offsets are 0, but now the work offset has changed. So the homing position, which is G53 machine coordinates, is showing would be 0. That's within the machine's memory, but that's not shown to us. G54 is shown, and the current, because that's our work offset that we're working with, G54 is showing a position of minus 253 on the X. Okay, I've just moved the camera a little bit, and because I want to show you something else. Okay, so now we've got our work offset at 253 in the X and 183 in the Z. We're in a new position now, and we've set our work offset with that number 1 tool on the end of the part. And I don't know how well you can see this, but if I measure from the micro switch of the homing position down to the cam, I get about 253 there. So in other words, that is the work offset set. Okay, just going over this again. We've set tool 1, and we've gone to the point of the work and set it on the end of the work in the center, and we've set the X and the Z on 0, 0. And we've used tool 1. Now it doesn't have to be tool 1. I'm just using tool 1 because that's the same tool number that Daniel Roger used in his video. I want to keep things as uncomplicated as possible. I won't get too deeply into that at the moment. So we are set here still on tool 1, and we've got the tool tip in the center of the work, and we're using a pointer to designate that. Now I'm going to shift that work pointer over to tool 2, which is this parting tool here. Okay, I've just jogged over now so that tool 2, the parting tool, is in line with the center and the end of the work. Now remember, we're not worried about getting it exactly right here. We're just talking about concepts or principles of how tool and work offsets work. Okay, so coming over to Pathpilot screen, you can see now tool offsets are still all on 0. That's showing our original G54 work offset is the same, but our DROs are all different. We've got 36 on the X, 21 on the Z, and 59 on the Y. Okay, so we've jogged the tool over to the parting tool. We're going to call that tool number 2. On our DROs, we're showing the offset from the first position, which we're calling our work offset 0, 0, 0. This is our first tool offset on the X, Z, and Y. Now let's just have a look at how we can enter that into the offsets table. There's our offsets table showing no offsets, and this is how we enter it. This is this very handy facility. Now we've got different tool orientations here. Currently the one that's lit up is tool orientation number 9, but we want a parting tool, which is that tool orientation, and we want to make sure it's tool number 2. So I'll just re-enter that into that now. See how it's green? You've got to make sure you enter it clearly and that it's showing here. Okay, we're just entering 02 at the moment. We're not worrying about tool offsets at this stage. But our orientation is wrong. These numbers here relate to different tool orientations or different tip alignments. And we want this tool orientation. So if we click on this tool, it's selected that tool, and it's showing tool orientation 2. That's not tool number 2, that's tool orientation 2. So I'll just do that again. Let's say we had the boring bar in there. That's tool orientation number 3. It might be easier if these were A, B, C, D, so you won't get confused with tool numbers. But we need to check two things: that we've got the correct tool number and that we've got the correct orientation number. So if we are unsure, we go to Reset Tool, we select the correct version of the tool we want, and it's checked that it's highlighting that tip orientation and tool orientation number 2, coincidentally the same as tool number 2. Now we're going to enter, because it's a pointed workpiece, we don't have a diameter value, we just put 0 there, enter twice, and here, because we're on the end, we enter 0 again, and let's do it a different way this time. We'll just push that button until the green light comes on. You either need to enter twice or push that button and enter. Okay, now you'll notice the DROs have gone to 0, 0. Let's have a look at what's happened. Here we are, tool table offsets. It's loaded it in to there. So it's gone from the main tool the main DROs here into tool number 2, and they're the offsets, showing the distance from the original work offset position. And then we would carry on and jog over to tool 3 and tool 4, set up the correct orientation number and the correct tool number. Now you can check that you've got the correct orientation number here as well. See, this is tip orientation number, tool number number 2. So if we go back to there, the previous one is tool number 9, which is that center orientation. Now that actually wasn't correct for my first tool because I didn't particularly set that correctly. I'm only zeroing in on it now. But this parting tool is correctly set at orientation number 2. Well, if we wanted to do gang tooling and we needed Y moves to different Y positions, we'd need to note down for tool 2 parting tool, there's a Y position of whatever's showing there, minus 59.8 and so on. Whatever position the Y is for each tool, and I'll explain more about that in a little while. Let's just give another example of the tool touch page. I've just indexed over to a hypothetical position. Let's say it's a boring bar. Let's say we want to call it tool 3. So we'll enter tool 3 here, enter, make sure it's showing, and let's go to our reset tool button. Let's say it's a boring bar. Let's say it's this boring bar, this orientation. So we click on that and we can check the tip orientation number is number 3, again coincidentally the same as the tool number. But we've got the offsets here showing on the main DRO, and we enter, in this case because it's a pointed work, 0, 0, not O, 0, touch, and we note down the Y, and if we go, see it's now 0 here, showing 0 on the main DROs, and now we have tool 3 showing those offsets in there, and the tip orientation number 3. That tip orientation number. It's unfortunate that it's matching up tool numbers to orientation numbers. There's a risk of confusion there, but they're not the same. Well, now that I've touched on Y, I guess I should go ahead and explain that a little bit more. Okay, so I'll just go over now, if you're doing gang tooling and you want Rapidturn to make Y moves to the different Y positions. Now, Rapidturn and probably Slant Pro doesn't have Y offsets in the tool table, so we can't have it automatically as part of the system. But Toolmac do allow you to do gang tooling, and I actually checked with Toolmac before I bought Rapidturn that this facility would be available, and I was very pleased to find that it was, and that it is available. If you go to settings, you can see here you can select manual tool change. That would be the normal position you'd have it in if you're not doing gang tooling, but if you are doing gang tooling, you can select it there. Then it will automatically move, it will allow movement in the Y direction. And the other thing I checked with Toolmac was, is there a Y DRO? And it's quite small there, but there clearly is a Y DRO, and it's editable. So this is brilliant. This means that you can do automatic production with Rapidturn via gang tooling. So okay, let's go to a file. Let's pull up a simple bit of code here, and let's have a look down to where the tool change is. Here we have a tool change, G30Z. Okay, so most of you will know that G30 is the position that you set the tool change to be at. So let's just back off here to a G30 position. That's well clear of the work, so all your gang tools are well clear of the work. And then you click on Set G30, so the software now knows to retract to that position each time. Okay, so that's that command there, G30. We've got a T0202, that's tool 2. Now we could type in here the Y move, but if you look down a little bit further, there's various commands to do with spindle and coolant, and we've got our first X and Z moves there. So you could put it in there, or you could put it here. Well, let's just put it there for convenience sake. Okay, so let's just go through that. Oh, I've just installed version 1.9.12, and it's got this nice little facility here to widen it. See the screen if you want a bigger view. You don't have to double click in this space anymore, which was a little bit hard to remember exactly how to do it. Okay, so say we want to enter that in there, so we just go to File, Edit G Code, find that position. Here we are. Use that little gap there, and we'll just go, okay, we're in lowercase, G0, Y0. So that's a rapid to Y0, if that tool change position was 0. But you might have noted on your bit of paper that it was 68.12 or whatever. And anyway, so then it goes to that position, runs that bit of code, you get to your next tool change position, and under the tool change you put in GO to the Y to the next position. So that's the basics, really simple. Just hand edit it into your code and you can do automatic gang production work. Brilliant. Here's an example of some code produced by the conversational facility T0202. Now you can have just T2, but I think the conversational facility automatically produces TO2O2 so that if there is a wear offset it will apply. But if you're hand coding, you need to be aware of that subtle difference. Do you want the wear offset to apply or not? If you do, make sure you have in the second number. Alright, well this is getting pretty long-winded, and if I carry on to the end, I think the video will be too long, so let's split it into part 1 and part 2. So the next video, part 2, I'll carry on with it. You might want to go and grab a coffee now, or come back to it tomorrow. Alright, cheers, thanks for watching.